Okay, so today we're going to do a little bit on regression equations, and you guys have looked into the prediction and manufacturing and just prediction in sports in general as you're reading through that chapter, and I think there's a lot of good information, and I want you to read through that. Again, I think this book is very good because it gives you a very good general overview of everything that's going on, but at the same time, you get some real-world examples and some really good case studies. So today we're going to kind of focus on regression equations because that's one of the things that you're able to calculate so that you can extrapolate or you can predict what may or may not happen. And so the first thing we need to do is talk a little bit about prediction and forecasting. And again, make sure you read the chapter. If you're unsure about what we're about to do, don't try to fake it, okay? It's not easy because there's a lot of things you have to go through and you have to remember, but you have to practice. And so as we go through these next few steps, there's only 11 slides in this presentation, make sure that you're comfortable with what we're doing. So the first thing I would say is that linear regression is something that you all have pretty much looked at. You've looked at things, you've probably tried to do it on your own, but basically you look at what variable you want to forecast in a sequence of observations. And so you think about on a time frame what you want. So you say, okay, what's going to happen next month? What's going to happen next year? Here are my ticket sales for 2015 and 16. What can I anticipate or what can I predict my ticket sales are going to be for 2017, 2018? And one of the things that you can do with a regression equation is you can create that line of best fit and get a good estimate of where that might be. You keep everything in chronological order. It makes it easy. And you can calculate the correlation, which, again, if you're not comfortable calculating a Pearson product moment correlation, you need to go back and figure that out. And if you need help, let me know. But once you figure out that correlation, you can determine how strong that prediction is going to be. Does it always have to be a time-based component? And no. Okay, and I want you guys to think of a run chart and how two variables can be viewed. And so if we look at this slide that we see now, how well does the average number of hours spent studying predict GPA? Well, what you need are your variables, and those variables are going to be the hours of time spent studying, which you can see here that will go on the x-axis, and the GPA, which is going to go on the y-axis. So this person spent 15 hours studying and they got a 3.4. This person spent 25 and they got a 3.7. Well, once you determine what you're going to have, so your hours, that's your time measurement, and then your GPA, you figure out how it's going to be organized. This is your organization in the spreadsheet that allows you to calculate this correlation. And if we look, we have our hours, our GPA, obviously hours to hours, GPA to GPA, that's always going to be 1. So this correlation is really 0.51. Is that great? No, it's okay. And if we look at the scatter plot over here on the right, you can see it's pretty much all over the place. However, there are a great grouping of plots that kind of coincide with each other that go in this direction. And so without drawing the line, you might look at that and say, you know, we've got some stragglers around here, but right through there, it looks that as hours of studying increase, so does GPA. And so we go up and to the right. So, how are we going to calculate it? Well, the first thing that we have to do is we have to remember what y equals mx plus b means. And I purposely did not put a bunch of transitions so that you guys can print this off and it'll look good. So, m is the slope. Okay, so y equals mx plus b. M is the slope of the line. And if you remember, slope, it's a delta y over delta x, so basically change in y over change in x. For example, a slope of 10 thirds, or 10 over 3, would mean up 10 on the y, over 3 on the x. Where b is going to be the y-intercept. And that's basically all that means is where the line crosses the y-axis and x is 0. So if b, in this particular, for an example here, let's say b is 5, then it would be 0, 5. So b is the y-intercept, m is the slope. Okay? So the slope and the intercept are going to be found on this regression output, and I'm going to show you where that is. And then once you determine what those two calculations are, then you can draw the line, and you basically it's a line of best fit, and and it will tell you what potentially could be happening in the future. And again, that's all related to what that correlation is. So when we use a regression tool, and I'm going to go over the instructions first, and then we're going to go over a video of actually how to do it. I would encourage each of you to either print this slide or really pay attention to the video, because this is assignment 3.2 A and B. Now, first thing you do is you select the data analysis tool option. A couple of you don't have this. I'm not real sure why you can't get it, because it's a free add-on for Microsoft Excel. I have a Mac computer and have it in mine, so if you do not have this and you use M, and if you use M, you'll know what I'm talking about, Control M, you would just select the regression, appropriate regression tab there. So you double click on that regression option in the data analysis box, click the open box labeled Y range, enter that. Same thing for the A range. So basically you're doing the Y and the X. Make sure you click labels. If for some reason you do not choose to click labels, that's fine, but you cannot start with cell B1 and A1 because that's where your labels are. By indicating that you're going to choose labels, what you're saying is the labels are the first cell in each one of these columns. Now, had you checked rows, you'll see an option for columns and rows, and you'll see what I mean there. You would be the labels on the row. Then you're going to check the confidence level box, and you're going to make sure it's 95%. So that means that you're 95% sure, 95% confident that something is happening or that these are going to be correct. And then you're going to click the output range button, and the output range just basically tells you I want the output in one specific cell, I want it on another workbook, or I want it on another worksheet. And once you click OK, you're going to get this printout. And so using the data that we use for average GPA versus hours of studying, we can come up with our R-squared, our standard error, total observations, there were 20. Your ANOVA printout, which some of you are using that in your research proposals and your research papers. And so hopefully you know degrees of freedom, the significance here, so P is 0.02. So as you look through here, this is going to be important, but right here on these coefficients, there is your intercept. Your y-intercept is 1.64, and your x is going to be 0.05. So y equals 0.05x plus 1.64. Now, if that number on the intercept would have been negative, it would have been y equals 0.05x minus 1.64. Now these other ones, they're fine. Here's your p-values. Those are your confidence intervals. So you've got those printouts within this. And honestly, when you are presenting data, when you're presenting your research, if you're going to present a regression, this is the entire printout. You want to include every bit of this. Now, once we get our scatter plot, we see this is the exact same scatter plot we had, and when we insert the line, here it is. Y equals 0.05 plus 1.83 or 1.64. And so this goes, and so we can tell that if we get to 40, if you study 40 hours per week, your GPA is going to be probably right around here. So you're almost at 3.9. So as this increases, there's a high likelihood, there was a reasonable correlation of 0.51. The confidence intervals were pretty strong that you're going to do well. There is a point of diminishing returns that we can talk about later. Maybe we'll talk about that on the next European trip, but probably not. But this is basically what you're looking for. Now, exactly how do you do it? Well, this is going to be the video, and we're going to go through this, and I want to kind of walk you through how we have our hours, we have GPA, and we've got this in an Excel sheet. And the first thing we want to do is select the Data tab and go over to the right where that Data Analysis Toolpack is located. Once we find it, we go down and we click the regression, and then we have our input X, input Y, so we want to calculate what that is. So here we have our GPA is going to be our y-axis, and so we go ahead and highlight that. And then our X range is going to be our hours, and so we go ahead and highlight that. Once we do, we double check that we've clicked that the labels are included, and then our confidence intervals are clicked at 95%. And our output range here, we want that to be C1, and so we click in that box, and when we do, you can see it's $C, $1, and then we click OK, And there we have the exact same summary output that you saw on the previous slides with our coefficients, where we can say that y equals 0.05 plus 1.64. Now, while we're here, let's go ahead and calculate the Pearson product moment correlation. In order to do that, we do not highlight the cells. On this example, I highlight the cells first. I guess I was getting a little ahead of myself there, but we're going to select the data analysis pack, and we're going to click on correlation. And when we do, we want to go back and we want to highlight the two groups that we're going to correlate or compare. And so we do have our columns and our labels in the first row checked. And so when we do get our range, we know that our output range is going to be just below that. We're going to select underneath. And so we're going to go down and we're going to click the cell. It's going to be A24. And that gives us a correlation. You see, again, it's 0.51. Now, to insert the scatter plot, all of you guys should be very familiar with this. We're going to highlight our two sets of data, and then we're going to insert. And when we go to insert, we can either use the recommended or we can go to the scatter plot option. And when we do, we see that GPA, which is Y, and that gives us our thing. And so one of the things that you could do is you could do the same scatter plot, and if you insert this and you do scatter with lines, and you see here, you're going to see that these lines kind of give you that line of best fit as you go through that. And so when you take that away and then you go to insert the regression line, you're going to see that it's very similar. So now we're going to click on the actual chart, and we go to chart design, and then we're going to add chart element and go to trend. And when we go to trend, we're able to do two things. And the first thing we're going to do is we're going to do a linear forecast. And when we do that linear forecast, we're going to find that that line goes exactly where we think it should go, and the slope of that line is y equals 0.05 plus 1.64. So as we look at this line, we can go in, and sometimes it's not that easy. So if we go back to our chart design, we go to add chart element, and we go to trend line, and we go to more trend line, and we select custom. And so you see here, we can actually select custom, and we can type in the equation y equals 0.05x plus 1.64. And once we hit enter there, the line's going to show up. And so because the line is exactly the same, you don't really see a difference there. But that's how you do that. That's how you create those forecasting lines. Now, this has been very simple. It's very straightforward, but most of these the key in all of these charts is organizing the data correctly. It's so important that you organize the data correctly so that you can go in and that you can do these calculations and make it very simple. Now, let's get off this slide here. That's one example of how forecasting can be used. And so right now you want to think about how you can use it in your world. And I used the ticket example earlier, but it could be in fundraising. The past 5 years we've been able to raise X amount of dollars. How can we, what is our anticipated revenue going to be based on what we're doing now? And so you can say, well, we went up 2% last year, and 4% the year before, and 3% the year before that. You can try to do some kind of crazy average and come up with some kind of crazy percentage, but it's not really going to work. So when you use these kind of equations, you have good statistical evidence to show that, hey, this is what we think it's going to be, so let's realistically use this kind of prediction. And there's all kinds of external variables that can affect this in any way. But another example might be free throw shooting, or maybe it's you're looking at attendance. Maybe you're looking at, staffing. Maybe you're looking at injuries. You have two examples that I want you to work on. Basically, these are two math problems that I want you to work on for the last 20 points of this assignment 3. It's going to be 3.2a and 3.2b, and they're each worth 10 points apiece. And I want you to go in and I want you to work through these. And basically, I just need the printout and the graph. And when you get this, it should be very easy. You can just attach that. You don't have to send me a bunch of description. You don't have to do anything. I need the printout or the summary, and I need the graph, and that's going to be what I'm going to go by to grade it with. So at this point, though, you guys should be very comfortable with some of this stuff. I know we haven't done a lot of the these type of statistics. So we're going to spend some time on this in the fall and make sure that you guys are comfortable with determining inter-rater reliability, determining correlations, figuring out validity, making sure that you can apply those things to a research proposal. Because again, at this point in the game, I'm not worried so much that you guys know every single detail, but what I need is, because you're going to be in supervisory roles, whether you're an athletic director, a coach, a supervisor, a project manager, you need to be able to look at the details that someone presents you and be able to pick out the holes. So typically the holes are very glaring. It's not in the details. Good solid research is good solid research, doesn't matter where it is. So hopefully this is going to help you put one more piece to that puzzle. And again, the equations are up. The two data sets are posted within the problem, and they are in Excel. So I will look forward to seeing your answers.